Hello, I'm Jenny Grosslight, here to demonstrate DDR3 protocol analysis and violation detection. For the demonstration today, we'll be using the Agilent U4154A logic analysis system and showing a new tool, the DDR3 Detective. A few of the tools that we'll cover today are the DDR3 decoder, the compliance tool set for analyzing the entire logic analyzer trace, and the Future Plus DDR3 Detective. The compliance tool set is actually 3 tools in one. We'll be covering the protocol violation tool in an example. We'll do a brief overview of the performance tool, and the physical address trigger tool will not be covered in this demo. The performance analysis tool will look at all of the valid commands across the entire trace, and will also provide a histogram of the refresh rate and the read-write activity across the entire trace, a bus efficiency utilization calculation, and a histogram view of all of the address accesses. For our first example, we'll be using the power of the logic analyzer triggering to capture a system hang. Our system would run for a short time at the 1.2 volt level DDR3 2088. When it hung, we observed the trace and saw occasional pre-charge refresh and reads, but no writes after the system had hung. So we made a trigger that would time out. We then added a colorized filter to show us the color pink on the waveform anytime there was a valid write. Our trigger worked great. The trigger is on the right-hand side of the waveform, zoomed out full, so all data is on screen. The solid pink area indicates that the system was healthy and had regular reads and writes happening. We're seeing the system running error-free, then the area where there's no writes, that's where the error started, and then the trigger point where the system had hung and timed out, having stopped doing any writes. Running the validation tool on the trace provides valuable information. Leading up to the hang, it appears that this system was regularly violating the read to pre-charge minimum. Instead of a minimum of 4 clocks, we were seeing violations where there were only 3 clocks. Looking at the listing, we can go to one of the violation areas and see that there are reads only 3 clock cycles, which are 6 samples apart from the pre-charge. Now that we see the error, we can follow the flow near the error and understand what our system was doing before and after the error. For our next example, we'll add the Future Plus DDR Detective for a real-time triggering on the logic analyzer. The Future Plus DDR3 Detective works on VGA probes, DIM interposer, or the SO-DIM interposer. The interposers provide the address, command, and control signals to the detective, as well as the address, command, control, and data signals to the logic analyzer for the full real-time violation detection and observation of all signal flow in your system. The DDR Detective provides a convenient display of violations in your system and shows you which ranks the violations are occurring on. You can set a trigger for the logic analyzer off of any one of the violations. In this example, the detective caught bus contention, where a write followed too quickly by a read on the same rank puts the data at risk. Thank you for watching. For more tips on how to make better memory measurements, you can go to either of the 2 links shown on this slide.